Hi, my name is SURYANATH, and I am an S4 civil engineering student. Today, I will be dealing with a problem based on the flexibility matrix method. So, we can start off by solving this problem by defining the system coordinates. Since the question asks us to find the deflection at the free end, we can add a dummy load at the free end. These would be our system coordinates. And as step two, we can define the element coordinates. For element coordinates, we can consider two beam elements with clockwise moments on each side. Being our first beam element and this being our second beam element. From this itself, we can define the element flexibility matrix for the first beam element. And the equation for the element flexibility matrix for a beam is L by 6EI multiplied by the matrix 2 minus 1 minus 1 2. Substituting in the values, we can get the flexibility matrix for the first beam element as now moving on to the second beam element. The equation for the element flexibility matrix remains the same. Now, by inputting in the values, by this we can define our element flexibility matrix as a whole as now our next step is to find the force transformation matrix. We can do this by applying a unit load at the free end Now we can draw the bending moment diagram for this. The value at the free end would be 0 and at the fixed end would be 5. Using the sign conventions, the value here would be negative, positive, negative, and positive. Now our force transformation matrix for R1 equals to 1 would be -5, 3, -3, and 0. Now we can do the same for the condition where R2 is equal to 1, and from our question, R2 is a unit moment that is being applied. The bending moment diagram for this condition would be this. Now, putting in our sign convention, the value throughout would be 1. So the force transformation matrix value for R2 equals to 1 would be -1, 1, -1, and 1. Now we have obtained the force transformation matrix as a whole. Now, the next step is to find the system flexibility matrix. As we know that the system flexibility matrix is equal to the transpose of the force transformation matrix times the element flexibility matrix times the force transformation matrix. On solving this, we get the value of our system flexibility matrix as 1 by 6 EI 152, 51, T1, and 24. Step is to find the displacement matrix R. Now, we know that the displacement matrix R is equal to the system flexibility matrix FRR times the system load matrix capital R. From the question, we can see that the system's load matrix is 0 and 20. And upon solving, we get the values of displacement metrics as 170 by EI and 80 by EL.